Today's question is worth 7 marks, and there are no parts A, B, and C. You just have to do it all in one go. So we're given the centre of a circle and a point that passes through, and we're giving 2 points on a straight line. We need to prove that L is a tangent to the circle. So to get started on this one, it mentions a circle, but there is no equation. So the first thing to do is to write out the equation of a circle and try and fill in all the numbers. So the equation of a circle in general is x minus something squared plus y minus something squared, and that should be equal to r squared. The centre is minus 1, 3, so what we can do is we can substitute them in to the brackets. The minus 1 becomes plus 1 because there are two negatives. The r squared we can't get yet. Use the information in the question. 1 minus 1 is on the circle, so if we substitute this in for x and we substitute this in for y, we'll get the value of r squared. Let's do it. So 1 plus 1 squared plus minus 1 minus 3 squared should be equal to r squared. And this means that r squared is going to be equal to, well, 2 squared is 4, and minus 4 squared is 16. So r squared is going to be equal to 20. Now putting this together, we have the circle equation. X plus 1 squared plus y minus 3 squared is equal to 20. Okay, now we've got that out of the way. The other piece of information given in the question are these 2 points, 1, 9 and 4, 3. Doesn't give you any instructions, but it tells you it's a straight line. So the most obvious thing to do is try and find the equation of that straight line. In order to do that, we're going to need the gradient of the line. So I'm going to call it m. I'm going to do y minus the other y divided by x minus the other x. This will give a gradient of minus 2. So the equation of a straight line, y equals mx plus c. We don't know what c is, but that's okay. We've got 2 points. We can sub one of them in. I'll sub in 4, 3. So this will help find c. So I'm going to add 8 to both sides. C is going to be 11. So y is minus 2x plus 11. So we've now got an equation of a circle. We've got an equation of a line. The question is to show that it's tangent. Well, if it's tangent, it touches. And when those two things touch or intersect, you've got to be thinking simultaneous equations. So we're going to take the y on the right and we're going to substitute in to the circle on the left. So minus 2x plus 11 and then minus 3. Square it all, should be equal to 20. I'm going to simplify and expand all this. So x squared plus 2x plus 1. And then I'm going to simplify what's in this bracket, minus 2x plus 8. And then I'm going to square that second bracket. This should be okay, just make sure not to make any silly numerical errors. And then I'll combine these two terms together to get 5x squared. I'll combine these two terms together to get minus 30x. And I'll combine 1 and 64 together to get plus 65. So that's still equal to 20. This is now a quadratic, so this should be very familiar. We want to get everything onto one side, so I'm going to subtract 20 from both sides. There's a brief glitch there. I've divided all terms by 5, and once I do that, then I can factorize it into x minus 3 all squared. This gives the value of x equals 3. Notice there's just one value. That's great because it's a tangent. And we can find y as well. Y is going to be minus 2 lots of 3 plus 11. This gives us 5. So just to conclude, x being 3 and y being 5 is the only point of intersection. So there is just one singular point of intersection. And that's exactly the definition of being tangent. If it only touches once on the circle, it has to be tangent to the circle. Therefore, the line L is tangent to C. And here are a few more to try.